What makes aconitide so remarkable, then, is not only that it's 1,000 times more potent than morphine on a per-weight basis, and it treats pain via a mechanism that no other pain reliever does by blocking calcium channels. But in this trial, as in several other clinical trials that have happened since, there does not appear to be tolerance with the use of aconitide. So here we have one drug from one cone snail that has become a tremendously important addition to our ability to treat chronic pain. And yet of the 700 cone snail species, only a half dozen or so have been studied in any detail, and a half dozen or so of the species have been studied in any detail, and only a few hundred of their peptides really characterized. Given that the snails as a genus may produce 100,000 peptides or more, that they have potentially unmatched specificity for and diversity of molecular targets, that out of just a few hundred that have been studied in any detail, at least 4 peptides are currently in clinical trials, and that one has already entered into use as a drug. Cone snails may represent the greatest treasure trove of potential medicines than any other group of organisms on Earth. And yet they live on or in coral reefs. Corals have been suffering under many burdens, including pollution, overharvesting, outright destruction, in some cases via dynamite or cyanide as a means to capture fish. But without question, the most clear and present danger to coral reefs today is climate change. Warming sea surface temperatures cause coral reefs, as you're probably very well aware, to lose their symbiotic algae and appear bleached, as is illustrated here. Bleaching events have become much more common in the recent past, and this is no surprise. When ocean temperatures exceed mean summer temperatures by as little as about 1 degree Celsius, bleaching invariably occurs. As the ocean absorbs about 80% of the excess heat in the Earth's atmosphere, climate models reliably predict that oceans under climate change will, within this century, warm to a perilously high level for coral reef survival, unless we take significant measures to reduce greenhouse gas emissions. Now, coral reefs represent far less than 1% of the Earth's ocean surface, and less than 3% of their area lies in marine protected areas. If we lose corals, we may lose cone snails, a genus with immense potential value to human medicine and science. Even with the protected areas, we are recently reminded that they are susceptible to human folly. At the start of this month, the 65,000 tons of coal in the Sheneng tanker from China ran aground on the Great Barrier Reef, which in fact is habitat for cone snails. There's another issue for coral reefs in our future related to climate change that you may have already heard about at this conference or elsewhere, and that is, as carbon dioxide gets more and more abundant in the atmosphere, it also gets absorbed into the oceans, making them more acidic. Acid is not particularly good if your skeleton is made of calcium carbonate because it dissolves it, and coral reefs, in addition to creatures like this, another name I'm sure I will botch, Limacina helicina, have calcium carbonate backbones. And as oceans become more acidic, we may be in fact leading to the dissolution of their skeletons. With climate change, then, coral reefs are additionally challenged by the presence of more acidic oceans. To take an overview, then, for a moment, of the value of natural products to drug discovery, if you look at all the drugs licensed by the United States Food and Drug Administration over the last 25 years, roughly 2/3 have natural product origins, which is to say we rely upon nature for new drugs today, perhaps as much as we ever have. So those are 3 examples to start with. One in a protected area in which we harnessed the bacteria that was incredibly valued medicine. One that was not in a protected area, and in this is an example of a species that has nearly gone extinct in the case of the axolotl. And then one example that is shows us that even in species that may be in protected areas, they may be vulnerable to insults from the outside, such as shipping. But when it comes to human health, species are, in fact, a very small piece of the pie when it comes to nature, and ecosystem services are critically important. According to the UN Millennium Ecosystem Assessment, more than 60% of vital ecosystem services today are in decline. They include things like air purification, water quality. In fact, a third of the world's 100 largest cities have purchased land or protected land explicitly for the purpose of supplying water to those cities. Ecosystem services also, of course, are what deliver us food and regulate our climate. I'm going to take a few examples of ecosystem services to illustrate to you the value of this unique and critical importance of biodiversity to our well-being. This is a close-up of a leaf. And you're asking yourself, what are those white specks? Did somebody scratch the negative? These are, in fact, particulates from the air. And trees happen to be a tremendous buffer of air pollution, including what are known as air particulates. These are small particles suspended in the air that can come from any number of sources, the grinding of stones, the combustion of fuels. And these particles are very bad players when it comes to health. Their concentration in the air we breathe directly correlates with incidents of sudden cardiac death, flares of asthma in children, worsening of chronic lung disease in adults. The benefit of trees, and particularly in urban areas, to human well-being was first documented in the Chicago Urban Air Quality Study done between 1991 and 1994. In that study, they found that the trees in Chicago, planted at that time, there were about 51 million of them, indicated that more than 6,000 tons of air pollutants, including SOx and NOx, the precursors to acid rain, ozone and particulate matter, were removed from the city's air on a yearly basis. A net benefit, strictly in terms of the economic cost of what it would cost to remove those air pollutants from the city's air, of $9 million. That does not account for the health benefits, which were incalculable. Now, the shade from the trees planted also reduced air conditioning bills by 2 to 6%. And it is from this study and others like it that occurred in the early 90s that cities around the world have embarked on major tree planting campaigns. Now, what's interesting about the issue of urban forests is that they're highly fragmented and usually planted in very limited patches. But in fact, changing an urban environment by planting trees has remarkable benefits, even if it is not a strictly speaking protected habitat. The second ecosystem service I'd like to mention is infectious diseases. Now, when we talk about ecosystem services, people rarely talk about infectious diseases being kept out of humans as an ecosystem service. We tend to talk about water, air, agriculture, and so forth. Well, it turns out that, in fact, ecology may be providing us with an essential service in keeping certain infections out of the human population. If you examine all emerging infectious diseases from the last 40 years or so, emerging infections being entirely new diseases you've never heard of before that come into the human population, these are the ones you read about in newspapers, or old infections like malaria or tuberculosis that we've known about for a long time but are greatly increasing in incidence, fully 3/4 of emerging infections are what we call zoonotic infections, meaning that the infectious agent infects not only humans, but other species. Compare that, in fact, to an analysis of all human infections. So there are about 1,400 things that infect humans. If you look at that, only 60% of infections are zoonotic. And when you compare those two numbers, you should conclude at least two things. One is that it is more the rule than the exception that the infections of humans are the infections of other species, and that, in fact, when it comes to new infections coming into the population or the spread of old ones, it is quite likely that ecological change may be playing a role. One example of this from the not-too-distant past and is relevant to Southeast Asia is a virus called Nipah virus. Now, Nipah virus is a bad player. When Nipah virus first appeared in 1998, Of 276 people who were infected, 106 of those people died. It emerged in a place called Ipoh, Malaysia. The economic toll totaled nearly $500 million. Now, there have been 7 subsequent outbreaks of Nipah virus. All of those have been in Bangladesh and Western India. And although they've been smaller outbreaks, the death rates were in fact even higher than the one observed in Malaysia. And what we must ask ourselves in this day and age is, why is it that Nipah virus emerged in 1998? Why did it not emerge 100 years before, or perhaps 100 years later?